One of the things you note here as far as when in Indiana we're most likely to have our severe weather, it's not right now. Although right now it's, we have the potential for it. Overwhelmingly, it's going to be March, April, and May in Indiana where you're going to find severe weather outbreaks. And the key to understanding that is in the springtime, there's a greater difference between air masses when they're meeting. In the springtime, you've got cold, dry air coming in contact with warm, moist air. Whereas right now, you've got kind of some warmish air from the Canadian area colliding with warm air from the south because it's summertime. Everything's warm for the most part. Whereas in the springtime, you've got conflicting air masses. Beyonce, let's say Beyonce and me. Those are some serious conflicting air masses. That probably wouldn't work out well. Anyway, she would destroy me. Anyway, and so here, right there, you can see this line right through here. That line is from the Evansville tornado. One of the things you will note about tornadoes is that they don't last long. There's a joke on the video lecture about that. They don't last long, but they're never more than a mile wide. They typically are quite thin as far as their destruction area. And so one of the things that's key to understanding, well, why did people die? Why do you have high casualty from, this is developed country. This is Indiana, developed state. Yeah, and so here, that was where a lot of the death toll was due to people getting hit by debris, which in tornadoes is the key killer, whereas hurricanes, it's not wind that kills people in hurricanes, it's a storm surge. It's people drowning to death from flooding. So with tornadoes, yeah, getting hit by shards of debris. But what happened here was that what happened here was that what the key was is typically these are in the afternoon. In the late afternoon, when the temperature of the surface is its warmest. And so all day long, the surface heats up. And so usually these are in the afternoon. However, in the case of this one, this came through at 1 in the morning. And so this is one of the rare ones in the sense that it came in the middle of the night. And so this is key to understanding why so many people died, was the fact that they're not getting those text alerts. They're not watching TV getting the rude beep, beep, or whatever the hell they do when they have that weather. This is a weather bulletin. They're not getting the radio updates because they're asleep. And so one of the things is this is why this one was deadly, whereas other ones, that happen they're much bigger, can actually have less death tolls. Key to understanding when this came through in the middle of the night. Let's focus in on two key events. If you remember these, help me out so we can have some bit of a useful discussion. And so what happened here? Case study, June 6th to 7th. This was a major flooding event. So any of you from the south side, any of you from Bloomington, Columbus, Martins, Tucky, Morris, Tucky, any of those places, you know this event. You know this weather event because you were essentially flooded. What happened here? Let's see. I bet the PowerPoint notes will tell me what happened, right? What happened was we had two weird things. We had one weird thing, let's say. Typically, these mid-latitude cyclonic systems, typically they move in a 3 to 10 day pattern. So every 3 to 10 days, we get a one coming through. We kind of wait for about a couple days, and then another one comes through, and so forth. The abnormality that happened here was we had two cold fronts, two major low-pressure cells that came together back to back within literally 24 hours of each other. And so what we had is we had two low pressures back to back, and thus with it, two major cold fronts came through back to back. And so when we have a cold front come through, that's when we're going to have those short, quick downbursts and a ton of rain in hardly any time, which thus a flash flood. And so here's day number one. We can see where these numbers are the highest in day number one. Anyone know that this is kind of Spencer, Indiana? Bloomington is somewhere in this area, right? Bloomington. There's the armpit of the state, also known as Terre Haute. Down here, Vincennes. And so it's kind of the south central Indiana area. And so that's on June 7th, 2008. On the next day, like I said, the abnormality was another low pressure came through in less than 24 hours and dumped a ton of rain quite quickly. So much that then over here, we've got Jennings County. Anyone from Jennings County? That's the meth capital of the state, by the way. Seymour, Indiana, Columbus, Indiana. And so then the next day, this area got dumped with a ton of rain from a cold front coming through. So we had this back-to-back situation, two separate areas, but we'll see why the flooding occurred near Vincennes. We'll see why that probably right now. 7 hours of rainfall. So just talking about 7 hours of rainfall produced. This would be the record in Indiana. But because it wasn't observed by a trained meteorologist, because it was observed by Joe the plumber or whoever, it's not official. But nonetheless, it still showcases 10 inches of rain. Trust me, that's a good amount of rain. That's almost like what they find like every day in South Asia, as far as the amount of rain they find there. But all these various places, Paragon, Spencer, are all south central Indiana that were heavily affected by this flash flood incident. And so the White Star is Naptown, where we are right now. And so the White Star, to kind of give you an idea of where we are. And so the purple, this would be an isoline map showcasing precipitation. The purple would be the areas that were hit that had the most amount of rain. And so the areas that have the most amount of rain would once again be this south central area. If you can kind of see, what's this guy right here? Or gal. Could be a gal. That's the White River West Fork. So we have a river coming right through here. You know, the river right here with all those dead bodies and syringes in it. That river right there, that's the same river that goes right through here. Goes right through this part of the state. And so keep that in mind. The fact we have a river that comes through this area that got dumped on with a huge amount of precipitation. Also, we got a river coming through here. This is where it's really confusing. This is the White River. This is the White River. Two separate rivers called the same thing. But the difference is one's called the West Fork, the other one's called the East Fork. And so we have the West Fork and the East Fork, which both together come together right here and then eventually dump into our good friend the Wabash. So that's key. And everything is going this direction. All the pretty much in Indiana, everything south of this area here heads towards the Gulf of Mexico. So right now, if I went outside and urinated on the sidewalk, eventually it would work its way to the Gulf of Mexico. Because everything slopes, works its way to the White River, which works its way to the Wabash, what have you. So here we can see actually it's an active remote sensed image in which they play with the colors to make it look like it's natural. And so here would be the before. And so what they did was anything that's kind of a murky brown, which would indicate floodwaters, areas of water on the surface. Anything that's murky brown, they go in the computer program. This is where GIS and people have jobs in geography. And they go in, they turn that muddy-looking brown into blue so that you can then visually easily see where flooding occurred. And so here's before the storm. Here's after. And so all those blue areas are where we see that flooding that occurred. And if you know anything about this area, yeah, it's largely agricultural, but a lot of people live along these rivers. If you think about before we had automobiles, planes, trains, and automobiles, overwhelmingly we lived along rivers because it was our food source, but our transportation source as well. And if we think about this, once again, there's our good friend, the White River West Fork, and the White River, the East Fork. We can see this flooding really hit this area right here, which is kind of interesting. I'll come back and describe this a little bit later in a future exam batch of material. But once again, water flows downhill. And so although the rain event was huge here, and a lot of flooding occurred here, a lot of flooding also occurred further downstream, and that makes sense. All that water just doesn't disappear. It all collects into this one area of what are these two counties? Vermilion, maybe, and Knox County. Vermilion and Knox County. So here, once again, we can see the before and after. And so a huge amount of flooding in this area. Here we can see the flooding that occurred. And so this flooding, once again, was due to two low pressures that came back to back, which is abnormal, and dumped a huge amount of rain as those two cold fronts, within 7 hours of each other, dumped all this rain. So here, this is Columbus. This is Columbus, Indiana. One of the problems they had there was their hospital flooded. And so one of the things is, what do you do when all of a sudden you've got emergency room patients, you've got kids that are being born, and so a lot of that, they had to actually move them out of that area because of the flooding. And where's Columbus? It's where the East Fork of the White River begins, to go back and use those previous terms. This is where Johnny Cougar Mellencamp's from. This is farmland in Seymour, Indiana. And so once again, a huge amount of rain that was dumped here. Then over time, the low-lying areas quickly flood. In this case, along a river, you're going to see a lot of flooding. And so you can see this from this image there. Anyone know where this is? You know your Indiana history. Where did that come from? You know your Indiana history because you can recognize by how? You do know your history. Great. George Rogers Clark Memorial. I don't know what he did. You can tell us after the class. Tell us. And so George Rogers Clark, there's his memorial. What that yellow line indicates is where actually the floodwaters were. They've actually, in this photo, receded. So this is the area close to Vermilion and Knox where I showed you where the flooding was the greatest. But it wasn't actually that day. It was 2-3 days later. Sorry, my fault. I'm spitting all over the place. It was like 2 to 3 days later that this area actually got the flooding, and that makes sense. Water just doesn't all of a sudden immediately 75 miles per hour get down the slope and get down to Vincennes. It's a slow process in which it all builds and builds and builds. So that's that flood. This here is, anyone know where this is? Here's your hint. Terre Haute. And so there's Terre Haute. Why do I call it the armpit of America? Because look at this. I mean, look how they built their city, all that garbage. Now we go to something that's obviously a little bit more contemporary and something we had to deal with just last year. And so here, once again, we have an example of a cold front that came through. One of the things that's we'll focus in on is how we screwed up, how the weather experts screwed up. And so the weather experts, if they just simply would have paid attention to G107, they would have been able to predict that, wait a minute, let's get out of here. Because this stage, who cares about the state? Well, obviously we care, but let's care about the people that are about ready to get dumped on by a huge amount of rain. So let's try to understand, well, what happened here? What happened in the State Fair stage collapse that we all know, I hope, fairly well? What happened was there was something called a gust front. And so, going back to our cold front, one of the things you see with the cold front, so here's our cold front. Cold air coming in contact with warm air. Cold air, it's heavier. It's denser. It's big and bad compared to warm air. And so what it's going to do is when it comes into contact with warm air, it's going to force it up. It's heavier. It's denser. I noticed this last night when I was taking a shower, or yesterday when I was taking a shower, my curtain was blowing in. Why was my curtain blowing in? Why was the shower curtain blowing in and hitting me, which was annoying me? I kept on kicking it back. What's that? Exactly. And so I had the door open. And so the cold air from the air conditioning in my living room was coming in, and cold air is heavier. It wasn't the top that was getting blown. It was the bottom that was getting blown. So all I did was I closed the door, and then the whole bathroom heated up, and then I no longer had that breeze. And so you didn't have that cold air difference, the cold air, warm air difference. Warm air, obviously, on the one side of the shower curtain, cold air on the other side. I don't know. I think about you guys all the time. Even in the shower. Anyway, so here I was wedging underneath and forcibly lifting up. And so we know this, that warm air has that quick uplift that creates that cumulonimbus cloud that grows taller and taller and taller over time. However, one characteristic, very important to understanding the State Fair stage collapse, was that with these intense updrafts, there's then an inverse or a counter downdraft. And so the counter downdraft we can often feel when you know this, when a storm's approaching. You can almost feel it. You can sense it. You can smell it even. And so that smell, if you don't know what I'm talking about, then I don't know. And so one of the things you can feel that cool breeze that comes before the rain. And that cool breeze that comes, also what it does is it turns leaves to go underneath. And so I guess there's any Navy people in here? I guess there's some deal where if you see the other side of a leaf, that means the storm's coming. You've heard that. So I'm not making up. Great. And so the idea with the wind creates a downdraft, which turns those leaves upside down so that, okay, you can just by looking at that tell that a cold front's coming through. And so that downdraft precedes the rain. And so you can feel that downdraft. You can feel that cool air. You can feel that. You can smell that rain before it even comes. And so that downdraft essentially is what we have here when we think about this gust front. So a gust front, also known as an outflow boundary. It arrives just before a cold front, and sometimes it's several miles ahead. In the case of Indianapolis, as we'll see here in a minute, it was only about two miles ahead of the intense rain. And so what we had with the State Fair's collapse was we had a major wind event. It wasn't a rain event that caused the death and destruction. Instead, it was a wind event which created that. And that wind event is from that downdraft. Reason you feel cool breeze, yep. Also read, yeah, exactly. Suddenly, for those English majors, suddenly, then falls once following cold front arrival. All right, I just showed that. So here we can see that downdraft that occurs with this cumulonimbus cloud. So here's what I did. So what I did was I went in and looked at a bunch of weather data. So one of the things I noticed was at 8:53 p.m., which is about 15 minutes before the stage collapse, what we see is we can see a huge temperature difference. Once again, what fuels storms? What gets them, all revved up is conflicting air masses, opposites on both sides. And in this case, this is where the State Fair is, right here. And this is Eagle Creek. And what's that? About 15 miles, probably. 15 miles difference. 15 miles difference, and there was a 20-degree difference in temperature. So here we have, obviously, much different air. And so this showcases, where's the cold front? We don't know. It's somewhere in between the two. We know that because here cooler temperatures, and there much warmer temperatures. And so here's the sucker in motion. And so what we're going to be doing is we're going to look at this cold front, and we're going to look at this low pressure that formed. And it formed up there in northern Illinois. And it formed about 4 o'clock in the afternoon. So about 4 o'clock in the afternoon, if you were just an average G107 student, you'd be able to recognize that this storm is going to hit Indianapolis. There's no question about it. Let's see if we can see this. There's that low pressure. There's the cold front. Boom, there's it coming through. And so once again, this isn't a deal where, it came out of nowhere. How in the heck did this all of a sudden surprise us? No. This sucker started way out here in northern Illinois and worked its way right across the western part of our state. And so it shouldn't have been something that surprised anyone. So just the pure rain event that was guaranteed to happen should have been enough to cancel the show. Because there was no doubt that it was going to downpour big time. There's no way they were going to get it in. This is a Doppler map showcasing precipitation. And you can really see that line right there. Anytime you see these clouds that are very linear in shape. What I mean by linear, look at that. That's almost a perfect line there. That's a great example of a cold front. If it's kind of messy, that's a good example of a warm front. This is a perfect example of a cold front there. As far as you can see that line right there. Boom. That line wasn't going to die down. It wasn't all of a sudden going to peter out. And so that should have been, once again, more reason. Here we can see a closer look here at the storm hitting Indianapolis. One of the things you'll note, right there, what do you think that line is? Right there, just ahead of it. Boom, that's the gust front. And so what that is that's essentially a wind thing. And so what you have going on there is you got that downdraft, that cool air that was downdraft so much and was moved out ahead of the front that it actually started to rise and condense and cool to form a little bit of precipitation that could be seen here by this Doppler. And so this line right there, coming out of that cold front, is the gust front, the outflow boundary. When did it originate? When did it start? Essentially right over Indianapolis. So it was pretty much right over Marion County, 15 minutes before that stage collapsed, that this gust front formed. And so here we have 8 p.m., 8:12 p.m., 8:21. We're getting closer, and you can already see that gust front starting to form. You're going to see this line, see where Whitestown is. You're going to see this line continue to develop as this cold front comes through. And so at 8:39, there was a severe thunderstorm warning. And so once again, the State Fair people ignored the severe thunderstorm warning that once again, we could see that cold front coming. There's no way it was going to be stopped. But of course, they kept on keeping on. So here, that gust front, we can see it as it continues. The red dot illustrates not downtown, but where the State Fair is located. And so, boom, 8:53 is the gust front has arrived. And so 8:55, of course, is when the stage collapsed. And so this 8:53 p.m., we can see that outflow boundary which was actually, what, 5 miles ahead of the precipitation. And so, once again, do you see any precipitation in this image here? No. What you see a ton of is what? Dust. So dust, if you know anything about the state fair, it's got this dirt horse track that surrounds the stage. And so essentially, all that wind was just coming, that downdraft was coming, and it just essentially is what toppled everything. And so everyone was like, we got 15 minutes before the storm gets here. But the gust front, they didn't prepare for the gust front. They didn't plan for the gust front, which then, of course, toppled the stage and caused it to collapse. And then finally, 8:58, they finally say, "Hey, State Fair, you need to get you need to get people cleared out," which obviously by that point was 3 minutes too late.
Back to the downward picture. What's that symbol?
That one?
No, the other one.
That is that's the airport. That's where the radar's on the ground, and so the radar kind of like does this. It points on the ground, and so because it's so close to the ground, close to that point right there, it picks up a lot of moisture on the surface. And so what they do is they just black that out, because even when it's super dry out, it'll actually pick up moisture on the surface, just because that's where the radar is coming from. If that makes any sense. So that's over by the air. I think it's the old airport where they have all that weather sensor stuff. I never even noticed that. Yeah, cool. All right, so the stage collapse, boom. And so one of the things, the storm was expected at 9:15. And so why did they expect the storm to arrive at 9:15 when it actually arrived at 8:55 or whatever? Once again, the gust front preceded the cold front, preceded the rain, preceded the 9:15 weather event that they were expecting, and thus caused the damage. But we know anything. If you know anything about music, I mean, you got what, 20 minutes to play before rain comes. Is that really worth it? I don't know. I don't know the band. Maybe it was worth it. What, Silverchair? What are they called? Sugarland.